All right, let's get right into it. Today, we are talking about the single hardest, most important choice you'll ever make when you're building a system at scale. This isn't about picking a programming language. This is about the fundamental laws of distributed systems. This is the CAP Theorem. So here's the core challenge, right? You have to build a system that spans the entire globe, a system that can never, ever fail. But here's the catch. You have to build it using parts, servers, networks, all of it, that you know are unreliable. You know they're going to break. So how do you build something reliable out of unreliable pieces? That is the billion-dollar question. To figure that out, we need to define the promises we can make to our users. Promise number one is consistency. This is simple, but it's powerful. It means that every single user, no matter where they are in the world, sees the exact same up-to-the-minute data at the exact same time. It's the promise of a single source of truth.
Promise number two, availability. This one's even easier. The lights are always on. When a user makes a request, they get a response, period. The system doesn't go dark even if half of its servers are on fire. It always answers the call.
And finally, our third promise, partition tolerance. This is your disaster plan. This is your system's ability to survive when communication breaks down. If that critical network cable between your data centers gets cut, the whole thing doesn't just fall over and die. It keeps on chugging. Now, for years, the way this was taught was with this neat little triangle. You have consistency, availability, and partition tolerance, and the conventional wisdom was you can only pick two. It was presented as this clean, simple trade-off. You want a system that's consistent and available? Fine, but you can't tolerate partitions. A simple choice. Or so we thought. And hey, this should be ringing some bells. Remember way back on day 7 when we talked about replication lag? We made a conscious decision to accept that our data might be a few seconds out of date. That was us choosing to take a hit on perfect, instant consistency. And even more critically, remember day 18? We talked all about heartbeats. Why do we even need them? Because we know for an absolute fact that servers get disconnected, networks fail. We learned that network partitions aren't some weird edge case. They're an inevitable, unavoidable fact of life. So, if we know for a fact that partitions are going to happen, what does that do to our tidy little pick any two choice? Well, what if I told you that choice was a complete illusion? A myth that's been leading engineers astray for years. Just picture this in your head. You've got two massive humming data centers. One in New York, the other in London. They're connected by this incredible glowing green fiber optic cable running under the Atlantic. Everything is perfect. And then, a shark gets curious and bites the cable. It snaps. That glowing green line on your dashboard goes dead, and all your servers turn bright red. That, right there, is a network partition. This quote from Alex Su just says it all. Since network failure is unavoidable, a distributed system must tolerate network partition. That's the key word right there, must. It's not a choice. It's not a feature you can opt out of. It's a requirement to exist in the real world. So, reality check. You don't get to choose P. You never did. The universe, with its sharks and its construction crews digging in the wrong place, chooses P for you. You are forced to be partition tolerant, which means that whole pick 2 out of 3 model, it's just wrong. So what's the real choice, the only choice that ever actually mattered? It's what you do when that partition happens. In that moment of failure, you have to choose. Do you sacrifice consistency or do you sacrifice availability? It's C or A. That's the real fight. Okay, let's explore path 1. I call this the stop sign. This is the path where you prioritize consistency above all else. When the network breaks, you slam on the brakes to make sure the data stays 100% correct. This is a CP system, consistent and partition tolerant. The perfect example is a bank ATM. Imagine it loses its connection to the main bank's database. You try to withdraw $100. What should it do? Well, to guarantee consistency, to make sure you actually have that money, it has no choice. It must reject your withdrawal. So what you, the user, see is a service unavailable error message. The system basically put up a giant neon stop sign. It chose to be absolutely correct over being online. It sacrificed its availability to protect consistency. That is the CP trade-off. Now for path 2. This is what I call the Polaroid. Instead of a stop sign that halts everything, you give the user an old photo. It might be a little faded, it might not be perfectly up to date, but it's something. You're prioritizing availability. This is an AP system. Think about scrolling on Instagram. A network partition happens deep in their infrastructure, splitting their servers. Does the app just crash on you? No way. It keeps working. You can still scroll your feed, look at pictures, and like posts. Now, you might be seeing posts from yesterday. You might not see that brand new photo your friend uploaded 30 seconds ago. The data isn't perfectly consistent, but the service is still up. It's available. The system made the choice to stay online, even if it meant being a little out of date. So you get it now, right? When the network breaks, you pick consistency or you pick availability. It seems simple enough. But what if I told you the hard choices don't actually stop there? Let's just imagine a perfect world for a second. The sun is shining, there are no sharks biting cables, no network failures whatsoever. Every server is talking to every other server perfectly. You'd think, finally, I can have it all. Perfect consistency and perfect availability. Well, not so fast. Even in that perfect world, without any partitions, you still face a fundamental trade-off. Now the choice is between low latency, making your service lightning fast, and that strict, perfect consistency. And that's a whole other can of worms called the CAP Theorem. So, now you know the unbreakable law of distributed systems. But what happens when we need to build an app where data changes every single millisecond? Think of a live chat app or a stock ticker. Standard HTTP just won't cut it. And that's why tomorrow on day 27, we're going to build WebSockets. You're not going to want to miss it. Go on and hit subscribe.